This lecture is going to be about balancing chemical equations and reaction types. Here's the warm-up. How many of each atom are in the following formulas? Pause the video, fill it out, and then we'll talk about the answers. Alrighty, so you have NH4 in parentheses and there's a 3 on the outside. So just like regular schmegler math, this 3 on the outside is going to distribute and it's going to multiply and apply to whatever elements are inside the parentheses. So for nitrogen, there's only 1 because there's no number, so it's an invisible 1. So 3 times 1 is 3, you have 3 nitrogens. 3 times 4 is 12, so you'll have 12 hydrogens. The PO4 is not in any parentheses, so there's no multiplying that needs to be done, and P doesn't have any number, so it's an invisible 1. You got 1 phosphorus, and you have 4 oxygen. If you wanted to name this, it's ammonium phosphate. So this is 2 polyatomics. The next one is NH4NO3, and there's 2 of them. They're both nitrogen, even though they're separated, so there's 2 of them. There's only 4 hydrogens and there's 3 oxygens. And this is ammonium nitrate. The last one, CH3OH, again, we only have 1 carbon. We have 4 hydrogens because you have the 3 plus the 1 at the end, and then you have 1 oxygen. So balancing equations is really just looking at how many elements or how many atoms of each element are present on both sides of the equation and making sure they're equal. A lot of it will just be through multiplication and addition, and you'll see how. So 4.3, balancing chemical equations. You're going to learn how to write a balanced equation for a chemical reaction. In 4.2, we were writing unbalanced chemical equations, and now you will learn how to balance them and exactly what it means. So the law of conservation means that mass is neither created or destroyed, and it must be conserved in a chemical reaction. So however many atoms of an element are on one side, like the reactant side, they need to be the same on the product side. We don't just create new things in our world. Things don't just disappear, they just change forms. So that's kind of the beauty of chemistry. So steps for writing chemical equations, we're going to break it down to these 4 steps. First, you got to read the description of the reaction. 2, you have to write the correct equation, including the states. And 3, add coefficients to balance. You're not changing the identity, so we are not changing the subscripts. Coefficients is same as the vocabulary in your math class. They are the big numbers that go in front of your variables. The variables for us will be the compounds. Make sure that the coefficients are in the smallest integers, so that we want them in whole numbers. We don't want fractions, we don't want decimals, so you want them in the smallest integers possible. Just like when we're writing our compounds, you always want to reduce and simplify. Step 2 is very important in you feeling confident in your ability to write formulas for compounds, because if you write them incorrect, it will be very, very difficult to actually balance the equation. So let's do some practice. Liquid ethanol, which I give you the formula for, C2H5OH, reacts with oxygen to form gaseous carbon dioxide and water. Again, I really like to color code, but you don't have to if you don't want to. I like to just because it's easier to kind of see where things are coming from. So my red is for my reactants, and my blue is for my products. So here I have liquid ethanol reacting with oxygen. So I'm going to write ethanol, which is a liquid, reacting with water. In this case, it's probably, oh, whoa, why did I say water? Reacting with oxygen, which is going to be a gas. And you're going to form gaseous carbon dioxide and water. So we have carbon dioxide and water. This was a gas, and this is probably going to be a liquid. Next steps, we got to write the formulas. Write ethanol is given to you, C2H5OH, which is a liquid. Oxygen's that diatomic, so it's O2. Carbon dioxide is CO2. Gas plus water, which is H2O. So we've written our chemical equation, and now we actually have to balance it. So when I start balancing, I list all of the elements that are present, and I list them underneath the arrows because I need to make sure that both sides are equal. So I see carbon, hydrogen, and oxygen. So the amount of carbon I see on the reactant side is 2. For hydrogens, I see 6. And then oxygens, I see 3. On the product side, I see 1 carbon, 2 hydrogen, and 3 oxygen. Right now, the carbons and the hydrogens are not balanced, but the oxygen is. Although once we start putting coefficients in front of our compounds, that might change. Well, when I say might, I mean it will. I like to start with the biggest number. In this case, it seems to be 6, and hydrogen is the one with 6. So there's 6 on the reactant side, but only 2 on the product side. When you're putting coefficients in front of the compounds, they're going to multiply through. So whatever elements are in that compound will be affected by that coefficient. If I'm trying to get to 6, I'm going to put a 3 in front of that water, because 3 times 2 is going to give me 6. 3 times the 1, the invisible 1 in water, will be 3. But I can't forget that there's 2 from the CO2. So now I have 5 oxygens. 3 and 5 are a little harder to balance, so I'm actually just going to look at the carbon next. I have 2 carbon on the reactant side and only 1 on the product side, so I'm going to put a 2 there. So now I have 2 carbon, and now I'm going to have 4 plus 3 for my oxygen, which means 7. So I got to balance 7 on the other side. I have 1 in my ethanol, and then I have 2 for my just oxygen. Just thinking about it, if I'm trying to get to 7, well, I'm going to probably put a coefficient in front of that oxygen by itself. So in my mind, I think 7 minus 1 is 6. So really I need 6. In order to get 6, I'm going to put a 3 in front of here. And now I have a balanced equation. And you can write a little check. You can highlight it after. But this right here is our balanced equation. And these coefficients are as small as they can be. There is an invisible coefficient in front of ethanol. It's a 1, right? It's just, I wouldn't really write it. Invisible 1. There's always invisible ones in chemistry. Let's look at another example. Solid potassium reacts with liquid water to form gaseous hydrogen and potassium hydroxide that dissolves in water. Solid potassium reacting with liquid water to form hydrogen and potassium hydroxide that dissolves in water. Remember, that's going to show us our state of matter. It's not saying that water is a product. So we have potassium plus, and it's a solid, plus water, which is a liquid, forming hydrogen, which is gaseous, and potassium hydroxide, which is going to be aqueous. Next step is to put in the formulas. Remember to leave a little bit of space after the symbols, because that's where your coefficients are going to be. KOH, aqueous. Remember, hydrogen is a diatomic, and that's why it's H2. Next step is to list them all out. I see K, H, and O. 1, 2, 1. And then I see 1 potassium, 3 hydrogen, and 1 oxygen. Let's start balancing these equations. 2 and 3, usually I think about 6 as my magic number. I don't know if it's really going to be in this case, but what I'm going to do is I'm just going to try to get to an even number. And the easiest way to get to an even number is I see that there's 2 hydrogens already together for the hydrogen gas, but there's only 1 hydrogen in the KOH, and I want to get an even number, so I'm just going to pop a 2 in there, which changes all of them. And a lot of balancing equations is guessing and checking, so if you're balancing equations and it's just not going anywhere, I would just restart. So now that I've adjusted those, I'm going to pop a 2 over here on top of water. So I have 4 hydrogen, 2 of those, and now I just need to balance out my potassium. And here is my balanced equation. And it's in the most simplified way. Like there's no other way to reduce these and still have whole numbers. So that indeed is my balanced equation. In front of hydrogen, that's our invisible 1. So not all of them have to have some sort of coefficient in front of them. Sometimes only one of them has a coefficient in front of them. It really doesn't matter. It just needs to all be balanced at the end. Let's look at another example. Etching occurs when hydrofluoric acid reacts with the silicon dioxide in glass to form gaseous silicon tetrafluoride and liquid water. So I have hydrofluoric acid, and remember acids are aqueous, and I have silicon dioxide. Since it's in glass, it's probably a solid. And it's forming silicon, oh gosh. And let's respell that. Silicon tetrafluoride, which is gaseous, and water, which is a liquid. Next steps is to write this in as its actual compounds. So hydrofluoric acid is going to be HF. And it's aqueous, plus silicon dioxide, SiO2, which is a solid. Silicon tetrafluoride is SiF4, and it's a gas, plus water, and that's a liquid. Cool. Listing our wonderful elements. So I have 1, 1, 1, and 2, and then I have 2, 4, 1, and 1. The biggest number that's here is fluorine, so might as well make that match. I have 4 on the product side, but only 1 on the reactant side, so I'm going to put a 4 in front of HF. That changes my hydrogen, and it changes my fluorine. The next thing I'm going to do is probably change my amount of hydrogen on my product side by putting a 2 in front of water. That way I can at least get that to match. And it will also change my oxygen. So right here is my balanced equation. That was not so bad. And I can't reduce this any further without losing my integers. So there it is, balanced. You can write a little check to help you be like, it's balanced. Yay. Now, we're in 4.4, types of chemical reactions. You're going to learn how to identify the type of reaction. So there are 6 types of reactions. 1 is synthesis, 2 is decomposition, 3 is single replacement, 4 double replacement, 5 combustion, 6 is oxidation reduction. We don't talk about it too much in our class. You talk about it a lot more in advanced chem. And for our sake, because we don't talk a lot about oxidation reduction, when I ask you to classify the equations in the homework, if you can't classify it and it creates a gas, just say it's gas producing. It's all right. Or you can say it's some type of replacement. So sometimes it doesn't really fit into these molds, but it's one of these types of reactions. Ooh, that is supposed to be 4.4, not 6.4. So for a synthesis reaction, you're combining 2 or more reactants to make one product. Right here, we got H2 plus O2, and we're creating water. So that's synthesis. Decomposition, 1 reactant breaking down into multiple products. So you have NaCl, and you're breaking down to Na and Cl. Single replacement, 1 element switches places with another. So you see copper is by itself, and you have AgNO3 together. But then on the product side, you have Ag by itself, and now copper is with the nitrate. So that's single replacement. Remember, 1 element's got to be single. Double replacement. Your cations are switching places. So first hydrogen is with chlorine, and now hydrogen is with sulfur. Sodium is with sulfur, but now sodium is with NaCl. So your cations are switching places. Combustion, you have a fuel combining with oxygen to form carbon dioxide and water. Your fuel, sometimes these are also called hydrocarbons. So those are some sort of C and H compound. Sometimes there's like an O in there as well. So those are your fuels, like methane, propane, things like that, methanol. And they will always be burning in air, and it will always produce carbon dioxide and water. So if I'm asking you to balance and classify these using one of the 5 disgusting class, the first things we got to do is we have to list these out, right? H and O. I have 2, I have 2, I have 2 hydrogen, and I have 3 oxygen. So what can I do? Well, let's make this an even number. I'm going to pop in a 2 over here. That's going to be 4. That's going to be 4, which means I can put a 2 here, and that's 4 and 4. Seeing as I have 1 reactant, and then it's breaking down into multiple products, right? This is good to say that I can probably call this decomposition. Something broke down. Decomposition. Let's look at this one. C3H8 plus O2 producing CO2 and H2O. Well, here's our fuel. Burning in oxygen. And then making our CO2 and H2O. This is a combustion reaction. Let's balance this. I have C, H, and O. 3, 8, 2, 1, 2, and 3. I'm going to balance those hydrogens first. So I'm going to put a 4 in front of my water. That way I have 8, and now I have 6 of these. Balance my carbon next. I have 3 of those. 3 times 2 is 6, plus my 4 from my water. Right, 6 plus my 4, so I have 10, which means this is going to be 5, because 5 times 2 gives me 10. And there I have it, my balanced equation. Woo! Let's look at this one. Zinc plus copper sulfate produces zinc sulfate and copper. Well, I have one single element. It's single. And something's being replaced, so this is probably a single replacement. Let's balance this. Zn, Cu, SO4. So I put SO4 together because it's a polyatomic, and I see SO4 on both sides. If your polyatomic breaks apart or you just don't see it on the other side, do not list it as SO4, like as sulfate. Just list it as sulfur and oxygen. But in this case, it is on both sides, and everything is already balanced. What a great day. Look at that, our balanced equation. If that happens to you, you can just write already balanced. Let's look at this one. I have copper, not copper, I have carbon plus oxygen producing CO2. So this is multiple reactants forming one product. This is our synthesis reaction, right? So carbon, oxygen, 1 and 2, 1 and 2. Oh, wow, look at that. Balanced. Let me put this here. So if I asked you what coefficients were in front of this, hopefully you don't say 0 because remember, it's that invisible 1. So it's 1s all across. Let's look at this last one. KCl plus AgNO3 produces AgCl and KNO3. Well, it looks like our cations are switching places because potassium was originally with chlorine, but now potassium is with NO3. So this is going to be our double replacement. Let's list these out to balance. KCl, Ag, and again, NO3. I see it on both sides. So I'm going to write it as NO3. And it's already balanced. What a great day. So this is already our balanced equation. All right. Some of the homework problems are pretty tough when you're trying to classify them, but just remember if they don't fit into those exact models and they produce a gas, just say that it's gas producing. If you have any questions on balancing equations or reaction types, please don't be shy and send me a wonderful email.